Hello, Miss Walsh here. So we are approaching the last part of the chi-square testing, which is arriving at the conclusion. Remember, we're looking whether there's a dependence between certain two variables. Before that, just a quick reminder. In the last podcast, we learned how to populate these expected frequencies which come from values being mathematically independent. And remember at the end we covered a little shortcut. Instead of doing the probability separately, you can always just do the row total times the column total and divided by the grand total. So if you want, just quickly check yourself that you're able to do 19. So for this specific value, you would do 19 because that's the column total, 27 because that's the row total, and you would divide it by the grand total, and that would give you 8.55. Okay, so what are we going to be doing? We're going to be looking at whether, when these values are independent, whether the difference between the values that we observed, so collected from a survey, whatever, whether that difference is mathematically significant. Okay, before that, just a quick little concept. Remember, if in this example, so determine the average distance of 3 and 1 from the mean. Okay, so the mean here is 2, right? And you can clearly see that the average distance here would be 1. However, if you try to calculate this, okay, so if you try to do distance and you would do 3 minus the mean and 1 minus the mean, then what you would end up with is you would end up with 0, okay? And the distance here is not 0. Yes, if you account for the direction, it would be 0, but they're both 1 unit away, okay? So this concept about negatives and positives canceling out comes throughout. What we do in these cases is a lot of the times we will instead square it and square root. Perhaps you've already met that concept somewhere, and we're going to be using it today. And this is actually why the chi-statistics is a chi-squared statistics, because what we're going to be doing is we're going to be finding the difference between the values that we observed and the ones that we should have if they're independent, but we're going to be squaring it in order to have those negatives and positives not canceling each other out, okay? And then the other concept that we're going to need for today is just that middle school concept about the percentage change. So you remember how we do that, right? If your shoes went from 60 to 75, you always did the new price minus the original, and then it was out of the original price, okay? And this is exactly what's going to happen here. So what we're going to do here is we're going to find that difference, we're going to square it, and we're going to find that as a fraction of the value that we expect. In this case, this is like our original value, okay? Just a quick note, in case you haven't seen this before, this is a capital of the letter sigma, Greek letter, and it always symbolizes sum, okay? So we're going to be adding up all the difference between the value in each cell, squaring them, and doing that out of that expected frequency. And if you think about it, it has a kind of a nice common sense approach to it, right? You're finding how much the observed value deviates from the expected of the expected, okay? So here we are. And so what we're going to be doing is we are going to be doing, so first our observed, so you always match them up. So our first observed is 10 and our first expected is 10.45. So we're going to be going 10 minus, so we're finding that difference. We square it and we do it out of the expected value. So it's going to be out of 10.45. So just gonna go ahead and just type that on your calculator. You can set it all up first. 10 minus 10.45. plus, and then we're going to do the next one. Okay, so the next one is going to be, and it doesn't matter, it's a sum of the whole table, not the totals. So whether you go to the right or whether you go down is up to you. Okay, I'm just going to go down, but again, this is for no particular reason. So then the next observed is 9 minus 8.55 squared of the 8.55. And then the next one would be, we're going to go back up, and again, you can do it in any order that you want. So we would do 7 minus 11 squared over that expected being 11. Okay, and I'll let you finish this, and what you should end up with is you should end up with 7.085. Okay, this is our magic number. So this is kind of the average deviation of what we observed from the expected, but squared. Okay, and what this is called is, this is called our chi-squared statistic. Okay, and so now we need to decide, are we happy with this? I mean, obviously you're going to have some deviation from, even things can be independent, be really close to being independent, but still maybe it doesn't depend on gender, this course, but it doesn't work out to be exactly this. So we need to decide, is this a big number, is this a small number, and what are we happy with here. Okay, so this is where we need something called a critical value. Okay, critical value is our cutoff point of what we're willing to accept as the difference. Okay, the statistics behind of how this is determined is quite interesting. We have these tables, and it actually has to do with the area of the distribution, and this value is right here, and it's found by the size of the table and how much air you're willing to accept. So if you noticed, we're performing this experiment, we're allowing 5% air. But for you guys, it doesn't matter. You're always going to be given the critical value, so you'll always be given a cutoff. Okay, this is the difference you're willing to accept. And if it's greater, okay, so our difference here, so our chi-squared statistic is greater than the critical value, and this is our chi-squared value. If this is greater, then what we say is the difference from independence, we've deviated too much. Okay, something is happening that is throwing our observed values off so much that we are going to reject our null hypothesis. Okay, so the values are way off. The preferences that are given for the sport between the genders are thrown off. They're not balanced, and so they must be not independent. Okay, so probably the sport that is preferred is somewhat dependent on the gender of the person. Okay, so again, what did we do? We found the difference squared. Okay, so you need to make sure that you've got this formula handy. We added them all up, and then you compare this result to the given critical value, what you're willing to accept. And if it's bigger than that, you're going to be rejecting the H null. Okay, it's deviating too much from independence. Let's just take a quick look at the second one. And if you want to, you can pause it. I'm just going to take you through it again in a shortened way. So again, here, the critical value is 7.815. And if you notice, this is actually a bigger table. And we are again at 5% significance. So that value of 7.815 is coming from here. The fact that it's a bigger table, it has to do with something called degrees of freedom, but you guys don't need to worry about that this year, okay? So again, we're going to find our chi-squared statistic, and this is the Greek letter chi. It's not an x, okay? So we're going to do our observed minus our expected. And then we're going to do that all throughout. And I like to finish off the column. And then the next one would be 9 minus 7.125. Okay, finish it. Make sure that you finish it. And I know it's a lot of values. It's 8 values to go through. And what you should end up with is you should end up with 2.47 something. Yeah, I rounded a little bit. Okay, so let's look at what happened. In this case, our chi-squared statistic is less than our critical value. Okay, so our critical value here, what we're willing to accept, is 7.8. And it didn't get anywhere near. It's small. So yes, there is a deviation of what we collected in our data from what it mathematically should be, independent speaking, but this is small. So people aren't robots. Some people will like one, while some people like the other, but these differences are still close enough that we accept H null. Okay, so then our conclusion, you always need a concluding statement, is that I got in trouble at university if you don't have that concluding statement. And that is, remember what it was. This is why in step 1 we started by setting H null always, right? And we always assume independence, always, remember that. And so here we have that the type of music preferred or genre of music is independent of gender, okay? And this is used in statistics. This is used to find these different relationships between variables in the studies that you guys sometimes see published. Okay, so that's chi-square test. See you later.